presentation is on forecasting, and more specifically, how you can use the weighted moving average to predict important trends and statistics. The objective of our presentation is to forecast the number of wins a basketball team will have in the 2019-2020 NBA season. We've used 8 teams in our model: the Milwaukee Bucks, Memphis Grizzlies, Denver Nuggets, Phoenix Suns, Los Angeles Clippers, Utah Jazz, Boston Celtics, and finally the Minnesota Timberwolves. We selected these 8 teams because they've all been in the league for 25 years or longer, which provides sufficient historical data for which we can populate our model. The data source we used is basketballreference.com, which is the official stat website of the NBA. Finally, our presentation has 2 goals. The first goal is to calculate the weighted moving average for each of the 8 teams I just mentioned. The second goal is to build a model to forecast a random NBA team's future wins for the 2019-2020 NBA season. We've selected the Charlotte Hornets as our NBA team to model after, for reasons we'll make clear in the future. Let's jump right into the data. As you can see on the left side of our table, the season win statistics for the periods 1995 to 2019 are present. In order to calculate the forecast of season wins for 2020, we will be using a technique called the weighted moving average. This is a method that derives a forecast by calculating the moving average of a chosen number of past periods while assigning specific weights to each of these past periods. As you can see by our red weight table, we have chosen to use 4 periods, each with their own temporary arbitrary weight. Now for the Excel formula in which we use to calculate the weighted moving average. We will be taking the previous period and multiplying it by its respective weight. We will continue this process throughout. So 2018, or period T minus 2, is multiplied by 30%, 2017 by 20%, and finally 2016 by 10%. We will then divide this total by the sum of the weights, which should always be equal to 1. After quickly locking some of our cells, we will then drag this formula throughout the rest of the table. As you can see, in the lower right, our mean absolute percent error is 23.58%. However, we can actually achieve a more accurate forecast by optimizing each specific weight to its respective period. We accomplish this by going to Data and then to Solver. We set our objective as the MAPE, or the mean absolute percent error. We would like to minimize this. We do this by changing the variable cells, which are our weights. Finally, we add a constraint. We're going to set the sum of our weights equal to 1. After setting these parameters, we quickly press solve. As you can see, our mean absolute percent error actually dropped. A graph on the right depicts our results. The season wins are plotted against the forecasted wins. The forecasted wins actually have empty data for the first 4 periods because it needs 4 periods in order to actually calculate its first result. The final forecast in 2020 is present, and we've predicted that the Bucks will win 47.9 games, round up to 48. We've repeated this process for each of the other 8 NBA teams. Each one has its own respective weights because it has its own respective MAPE, or mean absolute percent error. As you can see, each of the weights are specific to the own individual model. To summarize, we have completed individual models and individualized each mean absolute percent error to each NBA team, but we can actually take this one step further. We've created a model that is able to predict the 2020 season wins for any random NBA team. As you can see in the left side of our table, the forecasted season wins for the Milwaukee Bucks remains the same. The difference lies in the Excel function. Milwaukee Bucks, amongst the 7 other NBA teams included in our model, share the same weights. You can see this in the Excel function used for the Memphis Grizzlies. Therefore, in terms of optimization, the red weight table shown here is shared by all 8 teams. The sum of weights will be equal to 1, similar to our last model. If we go to Data and then to Solver, we can see this process take place. For our objective function, we've created a new cell. This is the average MAPE amongst all 8 teams. The objective is to minimize this, as it aggregates the 8 datasets and finds the lowest possible average MAPE amongst all of them, optimizing weights only once. We would like to minimize that. Our variable cells will be our weights, and the sum of weights remains 1. These 4 weights are shared by every team amongst our model. Theoretically, we could use these weights and apply them to a random NBA team that is not included in our model. Let's do that. We've selected the Charlotte Hornets as our random NBA team because before the 2014-2015 season, they were actually the Charlotte Bobcats. They underwent significant management restructuring, so perhaps their performance before 2014 and 2015 wouldn't be an accurate predictor of their season statistics afterwards. Therefore, it's a perfect opportunity to apply our model and test for the quality of our weights. Using the same weights as our earlier model predicted, we've shown that the Charlotte Hornets should win 36 games in the 2020 NBA season. Thank you for watching.